in this section, we're going to be talking about simple interest. And this fits in really well with our last section about percentages. Remember we talked about percent increases and percent decreases? That's basically what simple interest does. Simple interest is a way to talk about money. Money is generally talked about in two ways. We are interested in the present value of money, and we are interested in the future value of money. Present value is what it's worth right now. Okay? It's what my loan costs. It's what my investment is. It's today. Future value is what I'm going to get at the end of a certain investment period. Now, there's always a question. Why would I invest money in a savings account, an IRA, another opportunity? Why wouldn't I just bury it in a jar in the yard or use a mattress, stuff it under there like in this picture? Why not just do that? And it's because we know that when we invest money, that we have the opportunity to earn interest. Interest is the money that the bank pays for using your money to loan out to other people, for one. It is the money that you get as a reward for investing in a company. So it's a thing where you actually get more money for having money. It's a great thing. Now, different books and different sources are going to use different variables for these, and I'm going to try to stick with what our textbook uses. So you may have found that if you've taken a finance class or taken an accounting class, you may use some different variables. That's okay. Here's what we're going to use. The concepts are still pretty much the same thing. Present value or principal, we're going to use a capital P for that. That's what the money is worth right now. This is the starting amount at the beginning of the investment or the beginning of the loan. We're also concerned with the future value, F. That's what the money will be worth at the end of the investment. A lot of books will have a capital A for this. Interest rate is always a little r. This is the stated interest rate for the problem. It's what the lender expects in return. I'm going to charge you 6% interest, or what your investor expects to earn. This IRA is currently earning 6% a year. Interest rate is always expressed as a decimal in financial formulas. So if the problem tells you that R is 6%, you need to make sure that you use 0.06 in your formula. If you put 6 in instead of 0.06, you're basically telling the problem that you want it to be 600% interest, which is out of this world. If you find something that will give you 600% interest, come and tell your math teacher, so she can retire early. Another interest concept that we're going to be talking about is annual percentage rate, which is APR. This is a standard way to describe the interest per year. Here's an example of a little snippet from a credit card statement. You'll notice that in the credit card statement, it says the APR, the annual percentage rate for purchases, is 18.99%. However, notice that if you are overdrawn or if you don't pay, they'd be happy to kick it up to 29.99% on this. If you make a late payment, you go over your credit limit. So the APR on a credit card is very, very high. You might want to consider that when you have that opportunity. All right. So we're going to be using the simple interest formula here. Simple interest formula has F equals, or your future value equals, the principal times 1 plus RT. Now, R is your interest rate, and T is your investment in years. How long of a year? This is very similar to our last section because you'll notice that I'm doing 1 plus an increase here. Given any three of these four quantities, you can find the last one. So you invest $400 today. All right, that's our principal. That's our starting amount. In an account earning 6.5% annual interest. So that's our interest rate. As a decimal, we're talking about 0.065. How much is your money worth in 6 months? And how much is your money worth in 5 years? So we've got two problems here. The one has T being 6 months, but T is in years. So that would be 6 months out of 12 months, or 1/2 of a year. The other problem says 5 years, so that would have T equal to 5. All right, so future value is the principal, 400, times 1 plus R, 0.065, times years, 0.5 for this case. And you should be able to type this into your calculator in one step using parentheses. I would type in 400, parenthesis, 1 plus 0.065. I'd probably use my times x here, times 0.5, and then close the parenthesis. So 400, parenthesis, 1 plus 0.065 times 0.5, close the parenthesis. And I end up with $413. So in 6 months, my investment will be worth $413. That extra $13 is interest. I could do this for 5 years as well. I'm going to take 400 times 1 plus 0.065 times 5. 400, parenthesis, 1 plus 0.065 times 5. And I end up with $530. Now that extra $130 is from interest. The next problem says you bought a savings bond 10 years ago. Well, there's your T. T was 10 years for $125, and now it's worth $200. Now don't get confused, because it's easy to say, well, now the money is worth now $200. But what it really is the start of the investment, which was $125, and the end of the investment, which was $200. So my principal starting amount was $125, and my future value is $200. So I can pop these into my formula. F, 200, equals P, that's 125, times 1 plus R, which I don't know, times T. Now, if I do that, I'm going to write down R times 10. I'm going to go ahead and write 10R. It's a little cleaner. You got to crank those algebra brains out. How do you solve something like this? Well, 2 ways to go about this. One thing you could do is you could distribute the 125 and solve it like that. Another thing you could do is divide by 125, then subtract 1, and then divide by 10. It doesn't really matter how you go about solving that as long as you get it solved. I'm going to go ahead and distribute. The algebra teacher and me just about can't stand it not to distribute here. So I'm multiplying 125 times 1 and 125 times 10. I'm going to subtract 125. That gives me 75 is 1250R. And in my calculator, I'm going to do 75 divided by 1250. And I end up with 0.06 equals R. Or in other words, R is 6%. Okay. You hear about an account where you can earn 12% annual interest. There's our R, 0.12. How much money should you invest today to have $5,000 in 4 years? Now, obviously, 4 years, there's our T. But what's 5,000? You have to ask yourself, is 5,000 the amount at the start of the investment or the amount at the end of the investment? And in this case, it's the amount at the end. So this is F. All right. So 5,000 equals P, the amount to start with. 1 plus 0.12 times 4. Okay. I'm going to simplify inside that parenthesis. 5,000 is principal times 1.48. 5,000 divided by 1.48. And I end up with 3378.38 for P. Or in other words, you need to put in $3,378.38 into this account. And if you do so, it'll be worth $5,000 in 4 years. All right, last one. I have $100 and I want to invest it in an account earning 4.75 annual interest until it is worth $300. How many years is this going to take? So I have 100. That's my present value. I want my R value to be 0.0475, 4.75%. And I want to do this until it is worth $300. So I want the future to be $300. What I'm trying to do basically is I want to know how long until my money is tripled. Okay, so 300 equals 100 times 1 plus r 0.0475 times t. Now again, you could divide by 100, subtract 1, divide by 0.075, that would work, or you could distribute. Either way is correct, and please just do whatever seems to make the most sense to you as you do this. Okay, so 100 times 1, excuse me, and 100 times 0.0475 is 4.75 t. I'm going to subtract 100 to get 200. And if I take 200 divided by 4.75, I end up with 42.105 equals t. Or in other words, it's going to take over 42 years. All right. Over 42 years for that money to triple. So this formula is very, very similar to the ones we did in section 10.1 about an increase. In this case, we're just increasing about a percentage.